And I'm pleased to welcome Levi Kaplan, who's a first-year PhD student at Northeastern. And you might ask, well, how's a first-year PhD student presenting a paper at IMC? And of course, the answer is, well, he was an undergrad at Northeastern before being a PhD student. So, Levi, you have the floor.
Great, thank you. I'm just going to move this. All right, hello everyone. Can you all hear me okay? Yeah, we're all good? All right, hope you're all doing well. Let's get started. So if you were to open up an American newspaper sometime before 1964, you might see something like this in the classified ads section, where you had job ads divided by the gender of the expected candidate, and often even explicitly stated the race of people who should apply. Now, obviously, a lot of things have changed since the 1960s. First off, today we see this as clearly discriminatory. It's been illegal in the US for decades. And the other thing that has changed is that advertising has largely moved online. So this process of deciding which people are ultimately exposed to which ads is now mediated by these platforms and algorithms. And this makes it much harder to determine how the information in ads, including ads for jobs, housing, and other opportunities, is shared across society. So in this work, what we wondered is this type of steering towards certain opportunities and away from others still occurring today, but veiled and obfuscated via these ad delivery algorithms? So to explore this, I will first describe a little bit of background on how online advertising works. So broadly speaking, there are two phases of online advertising. The first phase is targeting, where an advertiser tells the platform which users they want to show an ad to. And there's a lot of literature, including journalism by ProPublica, which showed that the targeting options that Facebook made available allowed for blatant targeting discrimination. And this is really important work, but it's not what we're going to focus on here. And the second phase is delivery. When a user is scrolling the site and an ad slot comes up, the platform needs to decide which ads get shown to that user. And this is done algorithmically in order to maximize metrics that can optimize profit, such as click-through rate. My colleagues at Northeastern investigated this on Facebook and showed that their ad platform algorithms, which make delivery decisions, can do so based on the ad's content alone. They found that Facebook delivered ads to vastly different demographics, despite being targeted identically, and the only difference being the content of the ad. So for example, an ad for bodybuilding is delivered mostly to men, and an ad for makeup is delivered mostly to women, and this is despite identical targeting parameters. And when the authors ran ads without the image, they saw marginal differences between the two ads, which you can see in this graph here. When they added the image, however, they saw the more pronounced skew in delivery. So this demonstrates that the ad image has a significant effect on who ultimately sees an ad. This issue may also present itself when considering ads that contain images of people. Advertisers are often very purposeful when choosing these images of people. So for example, my university is concerned about the diversity of the student body and wants to make it clear to all applicants that they would be welcomed. So they have diversity initiatives. And these three ads for our computer science graduate program all feature images of women, which is ostensibly to encourage more women to apply. But are these ads really delivered more to women? A BuzzFeed news article from December 2020 reported that some Facebook employees noticed they were being delivered ads for TikTok on Facebook, which featured dancing teenage girls. And one such employee discovered that this wasn't a bug. In fact, the advertising system was working as intended. So to quote, the social network's algorithm had been optimizing the ads for the audience interacting with them the most, middle-aged men. Could a similar effect be found with images of people on Facebook? So in other words, could the diversity campaigns my university is using actually be having the opposite effect, instead delivering these ads featuring young women more to middle-aged men? We know that advertisers use images of people for goals like diversity and outreach. So the question we wanted to answer is, when advertisers use images of people with certain demographics, how does the ad delivery algorithm respond? How does the demographics of a person in the image change the likelihood of an individual seeing the ad in the first place? So to answer this question, we want to understand how people in different demographics are delivered. And we need a range of images consisting of different ages with consistent gender and race. So to get these, we used images from the stock photo site Shutterstock. So here are examples of some pictures of white women with age varying across the slide. And we selected similar photos of white men, and black women. We then ran ads that differed only by their image, and we recorded the race, gender, and age of who Facebook showed our ads to. So here are two examples of these ads. We ran 100 ad images in total, and each differed only by the image. The copy, link, and ad targeting were all identical, and they were all run at the exact same time. To gather data for age and gender, it's actually quite simple. Facebook provides that delivery along the different age buckets for the binary genders of men and women. However, Facebook doesn't give delivery breakdowns by race. So in order to measure delivery along racial lines, we extend prior methodology and use location as a proxy. Here's how it works. We first take public voter records from two states, Florida and North Carolina, where voters self-report their demographics, including their race. We then create two equally sized and stratified lists containing white voters from Florida and black voters from North Carolina. We combine these two lists into a custom audience. A custom audience is a list of personally identifiable information from which Facebook can match users and send them our ads. We then use this custom audience as the targeting for a Facebook campaign containing our ads. Facebook gives us delivery breakdown by location, and we can now use this breakdown to infer the race of people who saw our ads. This is because we only have white people targeted in Florida and black people targeted in North Carolina. So we can count all delivery to Florida as a white person and all delivery in North Carolina as a black person. However, there are differences between these two states. So how can we be sure that the effects we are seeing is due to the race of the person and not an effect of where they live? So to control for this, we run another campaign containing the inverse. We divide the voter records into black voters from Florida and white voters from North Carolina. We create another custom audience from these lists, and again run a Facebook campaign targeting this custom audience. We can analyze state delivery in the same way as before to infer the race of people who saw our ad. We now have two separate campaigns that are inverses of one another. One is targeting white voters in Florida and black voters in North Carolina, and the other is targeting black voters in Florida and white voters in North Carolina. So the whole flow now looks like this. By aggregating the delivery to black voters from each state and white voters to each state, we can separate out the effects that different states might have on delivery, and we can be confident that the delivery by state is an accurate representation of the race of people who saw our ads. It's important to note that this methodology does not rely on any existing racial imbalances of the locations we picked, since we're specifically selecting individuals in the state whose self-reported race we know. So let's take a look at the results from this experiment. First, when measuring race, we found that pictures of white people were delivered to 56% black users on average. When we compare that to pictures of black people, we find that they were delivered to 74% black users, which is an 18 percentage point difference. Next, when looking at the average age of users, we find generally that the older the person in the picture is, the older the users who see that ad will be. Finally, let's take a look at gender. We see a pretty balanced distribution, with pictures of men being delivered to a 53% female audience and pictures of women being delivered to a 51% female audience. However, this aggregation obfuscates trends for intersectional groups. For one such intersection, we look at how images of women of different ages are delivered to female Facebook users. And here we see a concerning trend. Images of female children and older women are delivered more to women, but images of teenage and young adult women are delivered more to men. And this is illustrated by this U shape in the graph. When we look at the same intersection, but this time instead looking at photos of men, we don't see a similar trend. We instead see that generally the fraction of women go down as the age in the person in the image goes up. So this suggests that our university's approach of showing ads of our students may be having the opposite effect to what is intended. So you might be saying to yourself, Levi, this is great, but there are so many confounding variables in the images. This could be an effect of the background or how people dress or their head position, and you'd be right. We don't know right now whether this is purely due to the demographics of the person in the image. So to isolate the effects of demographics alone, we would need some way of gathering a bunch of images where the only variance is the demographic of interest. So we first start with StyleGAN, which is an architecture for creating computer-generated faces using a generative adversarial network. Here are two examples of faces that StyleGAN can generate. And we emphasize that these pictures are not of real people, they're entirely computer-generated. So now we have images of people, but we don't know how to control their features to make them look more like a certain demographic. So to do this, we first use DeepFace, which is a classifier developed by Facebook to give us the demographics that the image implies. We use a large number of these classifications as features in a regression to give us directions in the latent vector space, which corresponds to the image looking more like a certain demographic. So for example, we can take this person and we can move them in the latent direction for age to make them look younger or older according to the classifier. We can make them look female according to the classifier, or we can make them look white according to the classifier. So this set of images represents one quote-unquote person classified as 5 different age groups, male or female, and a black person or a white person. And we do this 5 times for 5 separate people who all vary only by a certain demographic change. In the same process as our previous experiment, we run ads that differ only by their image and measure age, gender, and race in that same process. So let's take a look at our results. First, when measuring race, we found that pictures of implied white people were delivered to 55% black users. When we compare that to pictures of implied black people, we find that they were delivered to 79% black users, which is a 24 percentage point difference. We next take a look at the gender breakdown. Here we see a bit of a less balanced distribution when compared to the stock photos, with pictures of implied men being delivered to a 42% female audience, and pictures of implied women being delivered to a 55% female audience. We again look at that intersection of how images of implied women of different implied ages are delivered to female Facebook users. And we see the same trend as before. Images of implied female children and older women are delivered more to women, but images of implied teenage and young adult women are delivered more to men. And we again don't see the same trends hold for pictures that are implied to be men. We instead see that generally the older the person in the image is implied to be, the more that ad is delivered to male users. This supports the conclusion that the demographics of the person alone are likely what's causing this difference in delivery. However, we don't know right now statistically how the different demographics components contribute to delivery. And we want to find a way to tease apart the effects that the different demographics of the images may have. So to accomplish this, we run a linear regression analysis to measure the statistical significance of our stock photo results. We also performed a similar analysis for our StyleGAN results, but we don't have time to go over it here, so feel free to check out the paper or ask about it after the talk. We measured 3 different target variables: percent delivery to black users, percent delivery to female users, and percent delivery to users aged 65 or older. We first analyzed the R-squared values, which is a measure of how much of the variance in the target can be explained by our features, which are the demographics of the person in the image. For the percent delivery to black users, we see our model explain around 62% of the variance. Our corresponding model for percent female explains 26.2%, and the one for percent age 65 plus explains 46.4%. This indicates that the demographic information contained in an image is in fact relevant to the differences in demographic makeup of the delivery of their audience. We next analyze the coefficients of the model. In brief, these coefficients measure the statistical significance of different features of the model, which here represent the demographics of the person in the image. For a model analyzing delivery to black users, the only statistically significant feature is whether the image contains a black person. For a model analyzing delivery to female users, the only significant feature is whether the image is of a child. We don't see women delivered more to female users here, as the coefficient for the feature female is not statistically significant. This can be at least partially attributed to men above the age of 55 receiving a disproportionate number of ads depicting younger women. So through our regression analysis, we see that our findings are supported statistically. Now, you might be saying to yourself, Levi, this is great, but these ads are just pictures of faces. They aren't a realistic representation of what an advertiser might run, and the effects might be exaggerated since nothing else is in the ad. And you'd be right. We've shown so far that there are some really interesting trends for how the implied demographics of people in Facebook ads affect those ads' delivery. But the ads we've run so far have been examples designed specifically for measurement. They aren't really likely to be run by any real advertisers. So we next wanted to ask, do these trends hold for more realistic ads like employment opportunities? So to investigate this, we run ads that contain backgrounds implying certain jobs, a link to a relevant Indeed page, and relevant copy. So here's an example of one for an ad for lumber, which talks about finding your next job as a lumber yard worker and looking for a job in the lumber industry. And there's obviously a picture of lumber. And we use 11 different jobs and run a total of 44 ads. So for each job, we run 4 separate ads with the StyleGAN faces overlaid onto the ad, implying the identities of a black adult and white adult for both implied binary genders. Let's take a look at the results of this experiment. I'll first break down this graph to make it a bit easier to understand. Each point on this graph will represent running 2 ads. One will contain an implied white adult, and the other will contain an implied black adult. The lumber ads from the previous slide are one such example of a pairing. The x-axis will represent the percent delivery to black users for the image with an implied black adult, while the y-axis will represent the percent delivery to black users for the image with an implied white adult. We first graph the y equals x line. This line represents our approximate expected graph if the face in the image did not affect delivery. A point above this line represents the incongruent direction. This would mean that images of implied white people in employment ads are more likely to be delivered to black Facebook users, and images of implied black people in employment ads are less likely to be delivered to black Facebook users. In contrast, a point below this line represents the congruent direction. This would mean that images of implied black people in employment ads are more likely to be delivered to black Facebook users, and images of implied white people in employment ads would be less likely to be delivered to black Facebook users. So now that we understand this graph, let's take a look at the results from the lumber ad set from before. When we graph the results of this experiment, we see a heavy congruent skew. The image with an implied black person has a much higher delivery to black Facebook users than the corresponding image with an implied white person. Let's take a look at another ad set. This one is advertising the janitorial industry and features an implied white and implied black woman. Yeah. So when we graph this ad set, we again see a congruent delivery. And when we finally graph the results from all of our ad sets, we see that the vast majority of our ads are delivered with a congruent race skew, and the amount of skew varies by job. We also observe, consistent with prior work, that the ads in different industries show clear differences in delivery along gender and racial lines. So for example, the ads for janitorial work are delivered disproportionately to black women. Our study sought to investigate the impact that the demographics of a person in an ad ultimately has on that ad's delivery. We thought very carefully about ethics, and I would be happy to answer any questions about our ethical considerations after the talk. All of our data is public at the site at the bottom of this slide. To recap our findings, we find that the delivery generally matches the demographic depicted in the image. When running job ads, we discovered a congruent race skew, where job images depicting implied black people are generally delivered more to black users than the corresponding job ad featuring an implied white person. The skews we observe may be what the advertiser desires in certain contexts. For example, employers seeking more diversity in their applicants may choose to depict diverse individuals in their ads. On the flip side, our findings show that non-diverse ads may be more harmful than previously thought. This is because in addition to minority groups being less responsive to these ads, they may not be delivered these ads in the first place. Our findings also bring up interesting legal questions under existing civil rights laws. But the real problem is that these effects are difficult for an advertiser to detect. We spend months and thousands of dollars, and even if they do know it's happening, there are no controls for fixing it when it is in fact undesirable. So we therefore propose, as a first step, increased transparency about how ad delivery algorithms influence who sees ads, and greater control for advertisers who do not wish for these algorithms to steer their ads. Thank you so much, and I'd be happy to answer any questions.